And I think we're live. Are we live? I don't know. We'll have to see for live here.
It says, I see a button that says live.
There we go. Now we can see your slides. Everything looks live. And, well, okay. So it's J Champions Conference. Is this the last talk of the day?
It is.
Yeah, it is.
Getting close to, okay, so you're the closer then. Awesome. So we're talking here to Paul and Gail Anderson of Anderson Software Group Incorporated. We've known each other for a long time, and they just give awesome talks on all kinds of topics, FX, Grail. I'm really looking forward to see this one, guys. And I'll let you guys do a proper introduction and just pass it on to you and drop out and have fun.
Thanks,
Please.
Kurt.
Okay, great. Thanks, Kurt.
No worries.
Hey, everyone. Welcome to the Java Champions Conference, where we are virtual everywhere. My name is Paul Anderson.
And I'm Gail Anderson.
And we are with the Anderson Software Group. And this is our session today. It's how we play the game, JavaFX and GraalVM. So who are we? Oh, hang on a second.
Oh, sorry.
There we
go.
Yeah. Okay. Okay. There we are. Okay, so who are we? Okay, Gail and I are Java Champions and Oracle Groundbreaker Ambassadors. We own a software training company in the US, and our courses include Java, JavaFX, Python, Go, Modern C++, and Docker and Kubernetes. We're the authors of 9 textbooks on software programming, and we have 2 books on JavaFX that you see here. For our latest book, which is the definitive guide to modern Java clients with JavaFX, we contributed a chapter on JavaFX fundamentals. And our other book is JavaFX Rich Client Programming on the NetBeans platform. We're also the authors of 2 live lesson videos from Pearson Education, one on JavaFX programming and the other on Java Reflection. Okay, so what's our agenda for this session? We're going to begin by talking about why we would want to use JavaFX on mobile. We'll then introduce the Gluon framework that we're going to be using for this. In particular, we'll be talking about the Gluon substrate tool, which allows us to make everything work the way we want, and also the GraalVM from Oracle that will help us create native images for the iOS and Android platforms. We'll also give you a mobile app roadmap for our demo program today, which is a game.
Say that really fast 3 times.
Yeah, mobile app roadmap. Yeah, I don't want to say that too fast. And we'll share a lot of experiences that we had as we developed this app, all the way from conception and design all the way to the app stores. We'll also be using the Gluon client plugin, and we'll show you how that works and why that's so valuable. And again, the goal here is to have one code base written in Java and JavaFX, and we can produce with GraalVM iOS and Android native images. Then we'll talk about how you can get your app up into the stores on Google Play and the App Store for Apple. And then we'll wrap it up with a summary, and the code will be available for you to look at on GitHub. And we will also make the slides available later in the week, and then we'll have questions at the end. Okay, so let's begin with why would you want to use JavaFX on mobile? A critical goal here is to have what we call platform-independent source code, where you write once and install everywhere. Instead of having 2 code bases that you have to maintain for both iOS and Android, it would be nice to have one independent source code, and being able to do all that in Java and JavaFX is very appealing. Now, to do that, you're going to need some help. So the design approach is going to be using the Gluon framework and their tools, and then the GraalVM platform for generating the native images that we need. There are a lot of advantages for using JavaFX. Not only do you have a rich set of components that will allow you to do modern and very compelling looking UIs, but you also have a scene graph model, you have nodes that you can animate and scale, and also you can separate the view from the model with a FXML approach. Gluon has a really nice drag and drop tool called Scene Builder that allows you to drag and drop components right on onto a palette, and then it will generate FXML code, which then can be loaded in your app, and that will instantiate and configure all of your components for you. The other really big advantage of JavaFX is that it has observable properties, listeners, binding techniques, and event handlers. And this is going to really help making your UIs easy to write and easy to implement. We should also tell you that JavaFX is very stable at this point and maintained by Gluon in partnership with Oracle. Gluon also has long-term support for the releases, and you'll have the same Java and JavaFX source code for both iOS and Android targets. And Gluon also has support for cloud and backend. Once again, all of this in Java.
And then I want to add that JavaFX is implemented as Java APIs. So when you use JavaFX, you get Java, which means you get stability and power.
Okay, here's a nice top-level big picture of the Gluon framework for you. On the left in the green box, you see that's your client application. And it talks directly to Gluon Mobile for you to use. And it runs on top of the Java client platform. Notice that Gluon Mobile will also talk to the native environment for the devices. So that means that you have direct access to low-level things like the phone and GPS and accelerometers and so forth. Gluon Mobile also will interact with enterprise systems in the cloud through another part of the framework called Gluon Cloud Link. And notice that it's decoupled, so they've got really nice ways to talk to these enterprise systems like Spring Boot and so forth through the Cloud Link program. And then you have very nice techniques to be able to use that with both Cloud Link and Gluon Mobile. And Gluon Mobile can also interact with third-party services directly. All right, now what does the structure for a mobile app look like? In Gluon, you have a mobile application class, which is the main class for your mobile apps, and this extends the built-in JavaFX application class. When you make up views in the Gluon world for your apps, they are actually factories that are called on demand. And the view class, one of the big things the view class does is it invokes the FXML loader for you, so it can read the FXML file that you have and instantiate the components for you and configure them. So that means you don't have to write as much Java code with constructors and setters and getters and so forth to do that. And this is called the presenter class. It's the FXML controller class, and it makes things really, really nice for organizing your code. You also have resources available to you. Besides the FXML, you have styling with CSS, and you have images, and you also have licensing files if you need them. Okay, I'm going to turn it over to Gail right now, and she's going to show you one of our apps that demonstrates how nice the Gluon framework is, and this is our BP Monitor app.
Okay, so what I want to show you right now is an application we wrote a while ago, and I want to show you because it specifically shows the Gluon mobile framework. And it's called BP Monitor. It's on my phone. I have my phone connected to my computer via USB, and I'm running QuickTime so you can see what is actually on my phone. So we're going to invoke this app called BP Monitor. So here we go. So now the nice thing about the Gluon framework is that it gives you controls that are specifically skinned to be mobile friendly. So when you have an app and you want to move it or develop it for the mobile environment, you have to worry about real estate. You don't have a lot, and you have to make sure that, in this case, we have a bunch of data that we want to display. So they have a really nice component called a charm list view that lets you display data in a whole bunch of different ways that's very highly configurable. So for example, you can scroll with touch events. The headers are programmable, sortable, and you see that they're nicely stacking as I move up. The ones that go off the screen disappear to make room for the other ones. The circular heart symbol is Gluon control called an avatar. And the headers is both programmable and sortable. Now this is blood pressure data, so you're entering data for systolic, diastolic, and pulse for any date that you want. Gluon also gives you nice material design icons, and we use these. You can see the pencil icon is for editing. So if I click that, we get the editing screen. Edit a reading that you've already inputted, or the delete button, you can delete it. And then the other component that's very important in the Gluon mobile framework is the floating action button, and that's the plus that you see down at the bottom right. And this is meant to be an action that's important for your application. And here, the plus is used to input a new BP reading. Now, as I said before, you have to worry about real estate, so you can't have multiple views at once. That would just be too crowded and confusing. So you have to have a nice way of navigating among your views. And in this case, we decided to visualize the data by using standard JavaFX charts. So the line chart icon at the top shows up to 10 readings at a time, but you can step through your data set and see how the blood pressure is changing. And whatever's displayed here, you can then get summary statistics in bar charts. You get maximum, average, and minimum for the free systolic, diastolic, and pulse readings. Okay, so that's all I want to show you with the BP monitor. Just want to let you know that we also did a version of this that stores the data in the cloud. This one stores the data locally on the device, so there's no login required. It's whatever's on the device. But we thought, oh, putting it in the cloud would be nice. And in that one, you do have to log in to make sure your data is connected to you, but you can access it from any logged in device. And if you modify it or add more data, it keeps synchronized among all the devices in real time. Okay, so that's it. We're going to go back. Slides.
Okay, so Gail just mentioned the fact that we had our data stored in the cloud. This is a very big requirement with mobile apps these days. Is the data should be stored in the cloud. So you should know that Gluon has ways of dealing very nicely with cloud databases. In this diagram here, we have Gluon Cloud Link interacting with a mobile app and then making REST calls to a database in the cloud. In this case, Oracle's database. And we're using a really nice tool in an app that we have called ORDS, which stands for Oracle REST Data Services. And when you want to do this, there are two ways to work with REST. You can use the Gluon REST API and make REST calls directly from your app. And this is not difficult to do, but the main disadvantage is that the REST endpoints will be hard-coded into your application. That means that any changes that you make to the REST interface is going to require upgrades to newer versions.
For your users. They're going to have to get a new version of the app.
Now, Gluon's Cloud Link has what's called a remote function feature that decouples your REST calls from your mobile app. You can also configure other remote functions for various providers, such as AWS and Azure, and your mobile app can invoke the appropriate remote function, and all the messy details for REST and etc. are separated from your application code. Another advantage of using this technique is it lets you configure Cloud Link so you could actually send mock values instead of the real enterprise data. And this will allow you to work on your UI code with mock data while the enterprise code is still under development. So Gail, why don't you go to our website here real quick. If you're interested not only in BP Monitor, but in the cloud database programs, we presented that last year at DevNexus in Atlanta in February. And the title of the talk was JavaFX Now and Beyond Desktop to Mobile. And you're welcome to download the code and watch that too if you want to see more about that. Okay, so back to where we are now. We're ready to show you our game and how we built it and designed it and how it's all put together. So the first thing that we want to learn about is the Gluon substrate tool. And this is a nice diagram that gives you a big picture about what this would look like. Okay, so up on the left, you have your Java application, and any dependencies that your application have can be expressed with either a Maven project or a Gradle file. And then underneath the Gluon substrate and the client plugins, you see you can use Java SDK, you can use JavaFX SDK, you can also use the open source OpenJDK and OpenJFX versions, and these will be static builds that you'll be putting into your app. And then in between those and below, that's the very important platform, the GraalVM, which is going to do what we call ahead of time compilation to build the native images for us. And then I already talked about Gluon Mobile on the lower right there to allow you to build your mobile applications with the framework and also providing you with access to the low-level devices. So what all this does for you, which is really nice, is on the right, you can use you can do all of your development with on either Windows, Linux, or Mac, and have it all on the desktop there. And then you can use the GraalVM platform to create a native image for your desktop or native images for mobile, where mobile again would be iOS, Android, and you can even create native images for embedded, which would be for like Raspberry Pi. Okay, now here's a suggested roadmap for mobile app development, 4 steps that we used, and we'll pass this on to you from our experiences. Okay, step 1 is local development with a JVM and desktop environment. Once again, you can do this in any of the 3 OSs that we talked about. This is where you would be developing your app, and it's very, very nice because builds are fast, and you can use debuggers, you can study performance, you can use other tools as you develop the code. You want to spend as much time as you can here in step 1 to get your app up and running and get all the bugs out. Now, step 2 is the install and test on the local device. And here you should know that builds are going to take much longer than Java bytecode builds. So you should move to this step only after you have, we say, coded, debugged, and tested your app with as much as possible in step 1.
And eventually you want to be able to do this install and test on local device for both an Android and an iOS device, because they're just different pieces of hardware.
So once you've decided that you're looking good at step 2, in step 3, you're ready to upload your app to the stores for beta testing and approval. You can use TestFlight for iOS, and you can use multi-level beta testing for Android. And once your app is approved, you can place your app in the stores for general access, and that would be the App Store for Apple and Google Play for Android. Okay, we're going to go back to Gail now, and she's going to show you how easy it is to use Gluon Start webpage here to create a mobile app and get started.
Okay, so one cool thing that I want to let you guys know about is that the environment, the development environment for creating JavaFX applications is evolving, and it's evolving a very good way. It's getting a lot easier. And one thing that Gluon has done is they created a web page called Gluon Start, and it's this URL, start.gluon.io, in which you can create a starter application. And this does a couple things. One, it gives you a starting point. Previously, to get this starting point, you would download one of their sample apps, which you can also do. But this gives you a better big picture. So you can see some of the choices that you have right in front of you. So for example, for JavaFX, you can choose the latest, but you could also choose an LTS version, you can choose early access version, or the 11.02 stable version. So in this little exercise I'm going to do, I'm going to keep all the defaults as they are. For modules in JavaFX, depending on what you want to do, you can choose different modules. And if you wanted to use FXML, which I am actually a big fan of it because it A, it lets you more easily design your UI using drag and drop, and B, it helps keep your just view only, UI only separate from your model and control code. However, we're not going to do that today because we're going to take all the defaults. Now, Gluon features, some of these features require licensing. So for example, Gluon Glisten, and that's what we use to show you the BP Monitor app, is does require license, but you could use a free version of it for experimenting to see if you like it. Glisten Afterburner is a minimalistic dependency injection. Connect lets you get data resources either from the cloud or locally, and Maps is a nice tool if your application needs to display maps. And we actually use Maps. We have another application that is a quiz on the world capitals, and we show you where these world capitals exist using the maps. Okay, so CloudLink is various ways in which you can either get data, do in-app billing, manipulate media, use push notifications, or keep usage. I think that's usage statistics. I'm not actually sure. And then finally, attach is a really nice way. All phones are different, and if you, for example, if you want to access the picture library of your user, or you want to access the camera or the magnetometer, if you want to do orientation things, you can select these, and Gluon has a device agnostic way for making calls to these different low-level units. Okay, so you do all these selections, and like I said, we didn't change anything. And then you click on Generate Project, and you get a zip file, and we're going to download it. And we're going to go over to our Finder, and we see that here it is. And we're going to unzip it. Go. And then there's a POM, a README file, and a source tree. So let's go over to our terminal window shell and change to the top level directory of our project. And again, you can see the files. Now, this is a Maven project. I've already installed Maven. And Gluon, what Gluon has is a client, JavaFX client plugin for Maven. So with this plugin that is defined in the POM, we can run the program locally on our machine using just the normal JVM and bytecode. And this is the development step that you would do at the beginning. So here it comes up pretty quick. There's a nag screen because Gluon Mobile. And you can see it's a nicely looking app. It has a status bar up here. It has an image of Duke waving. It has this is a label. And this is another example that I spoke about earlier of the floating action button. If we click it, you see that this word search comes down here. I'll do it again so you can see. Okay, so let's go look and see what this looks like in the IDE. So again, we'll have to open up this project. And here it is. Okay, so this is the POM file, and I just wanted to point out, yeah, we're using JavaFX 15.01 and the charm, which is the Gluon mobile commands. The modules that we specified show up here as dependencies. There's the JavaFX base, graphics, and controls. The charm glisten are the controls, and then these different attach dependencies is what lets us access the different low-level device features in a device-agnostic way. Another important thing is that Gluon provides what are called they enable profiles. And so you have 3 default profiles defined for you: the desktop, which is the host, and by default, that is what it builds to, and then Android and iOS. And there's other configurations that you can do that Gluon has really good documentation on some of that. So I just want to show you really quick. And we'll bring this back over here so you can see this. You see that the main program, and it's just a single program, it doesn't do much, but extends mobile application, and that's the Gluon mobile main class that in itself extends application, which is the standard JavaFX main class. Here's the floating action button. You see the Lambda expression here. Prints out search. I showed you that. The image view displays an image file, which is our openduke.png, which is also in the source tree. Here's the label that prints out hello Gluon, and here's the where we set the title for the app bar saying Gluon mobile. Okay. I'm going to put this, and we're going to close this. Active slides.
Okay, so Gail, is it time to play the game?
Okay, Paul's going to demonstrate mini golf, and he's been working really hard, so the pressure's on. So, oh, let me go back to this. Okay, so here's mini golf down at the bottom here, the green icon, and I'm going to bring it up.
Okay, so here is our mini golf application, and this is the splash screen for it, and you start the game by pressing the red button. And the first there's 9 holes to do. The first one's easy. There's not any barriers, so it's just a straight shot. So what you do is you put your finger into the start pad, and you can move the ball around, but you can't get out of the start pad. And let's move it right there, and then I let go with my finger. And then when I put it down, I have a dashed line that I can use to an aim line. And then the thing that you see at the top there is a power meter. And if I do that, it looks like I missed it. Okay, well, that's no problem. Okay, so we can just go here. And, the power meter is the speed of the ball, so I don't want to do it too hard here.
So the rule is if the ball is moving at too fast a clip and it goes over the hole, it goes over the hole and it doesn't go in. So you have to, sometimes you want the power meter at full strength, and other times you have to dial it back.
Right. Okay, now let's go to the hole 2. Now there's a barrier, so this is more challenging, right? Because you're going to have to do some banking. So once again, I'm going to put the ball here, and I'm going to move it over to the corner. And now I'm going to have to do a little bit of angling. And there's the power meter, so I'll let it go right here. Okay, so I'm a little bit off here. Let's try this. Missed it again, didn't I? Anyway, you can see you can bounce the ball around, and you can sit here and do this all day. Well, I'm going to turn it back over to you, I guess.
Okay. All right, so I'm going to quit out of this. And now what I want to do is show you a little bit about the project. So let's just look at the POM again really quickly. It's similar to the one that we just saw. We're using JavaFX 15. We're not using the Gluon charm controls in this one. So our purpose of doing this game was to get a very simple application. So this application is just one view. There's no login. There's no data that it stores on the machine. It doesn't do any cloud access. It doesn't do any it's not paid and it doesn't do any in-app purchases. It's really simple. So, but there was one thing that I wanted to use the material design icons for, and since I'm not using Gluon Mobile, which has material design icons, there's another third-party package called Iconly, and you can get material design icons from that. So we use that. Again, we have the desktop, the iOS, and the Android. And I think that's the important things to show. Okay, so let's talk a little bit about the how the game is kind of organized. So under other sources, we have all the holes, and they're just PNG files. So let's bring up hole 9. Okay, so each hole is just an image with the start pad on it. That's at a fixed location and size. And so what we wanted to do is we wanted to make this, we want to scale the images for the particular device. So if you play this on an iPad or a small iPhone, the images are going to scale to fill the screen as much as possible. The images are not all the same size and shape. Well, they're all rectangular, but their dimensions are different. So what we do is we scale the images according to the screen size. Then, so the flow for the hole is, and then we, for each hole, we define, so to have the images, and then these barriers are simply, the barriers are on the image, but to make them available for collision detection, we create rectangles that lay over where the barriers appear in the image. And so we have to scale the rectangles, the barrier rectangles, and the outer wall as well. So the flow for each hole, as Paul showed you, is you place the ball in the dark pad, and when you release it, then and press again, you can both aim the shot and the power meter goes. And when you release the shot, that engages it. And you do the barrier detection, and the ball either goes in the hole or it stops rolling. So let's leave that and look at the main program. And here we extend applications since we're not using the Gluon controls. But we look at the bounds, we get how big it is, and we make sure that we can scale everything correctly. Okay, now this is the main view is simply a stack pane, and all the elements of the game go on top of it. And let's go down to where we engage the shot. And basically, the constructor has all the event handlers that set up what you're supposed to do at different points in the game. So engage shot, this is when the ball starts rolling. So the power meter animation that goes on is paused, and we get the reading from the power meter. We do some, we get rid of the aim lines, we do some other housekeeping, and then we do the ball roll. So the ball roll is the main animation of the game. And here it is here. And we use a keyframe, and every, during the keyframe, update is called. And that's where you do the collision detection. You first see if you made the shot, and you do housekeeping with that, and you check all of the barriers. So each hole is different, and you can have 0 barriers, as you saw in the first hole, 2 barriers you saw in hole 9 that I showed you, but there can be 3, 4, 5, there can be many barriers. So you have to check all the barriers and update the ball roll rate and do all the housekeeping for that. Now, one last thing to show you is, as Paul mentioned, the nice thing about JavaFX is you have properties and binding.
Yeah, so I was just going to jump in here for a second. One of the things that I really like about JavaFX are the binding mechanisms. So if you look at line 175 and a couple lines above it, 72 and 73, you see one line bind expressions where you have a whole count property on the right and a scorecard property on the left. And that means that if the whole count changes or updates that property, then the scorecard property updates and you see the score automatically updated. That's one line of code. And there's even more fancier binding expressions that you can use. But JavaFX makes it really nice for doing UI designs with the binding mechanisms, and just wanted to point that out to you.
Okay, and I realized I forgot to show you that we did configure NetBeans so that when you hit the run bar, it does the Maven JavaFX run command. And this is an example of the material icon material design icon that we used. Okay, so I just wanted to show you that. So it's the same game. And this is how we developed and debugged it. Okay, so that's it. We're going to go back.
Okay, so Gluon has a Maven client plugin that lets you build native image apps for multiple platforms. You can target Mac OS, Linux, Windows, iOS, and Android. And as we mentioned before, the client plugin will leverage the GraalVM platform and OpenJDK and OpenJFX. Now, Apple prohibits JVM apps on mobile targets, and Android Java is not standard. So we need something to help us generate the native code for iOS and Android devices, all from one Java and JavaFX code base. So GraalVM has the ability to do that, and this is, again, an Oracle project and supported. It's actually a Java VM and a JDK platform, and it's implemented in Java. And this supports what's called ahead-of-time compilation, AOT compilation of your Java applications. And it creates all the native images for you and links in everything that you need. And a reason why GraalVM is so important for mobile apps these days is because when you get the native image, it has a fast startup and a low memory footprint. And those are important things to have in any mobile application. Okay, so let's show you how we set up the iOS target for the mini golf game that we did. You'll need a Mac with the Xcode development tools and an Apple developer license, which is $99 a year, and an Apple signing certificate. There's a certificate for installing on your own device for testing, and a separate certificate for uploading your app to the Apple Connect site. Now, to get GraalVM, you can get that, the community edition for the Mac, right? It's available on GitHub. And when you bring that up, you'll need to set a couple of environment variables. You'll need your Java home environment variable set, and there's also a GraalVM home for wherever you install it. If you're a Mac developer, you probably have Homebrew installed on your Mac. Therefore, you can use the brew command to install the native libraries that you need. And the Gluon client plugin will generate default configurations for iOS-specific settings, such as a plist file and a default icon set. For mini golf, what we did was we modified that plist file to allow only portrait mode, and we customized the default icon set. And there are some app icon generators, and Gail's going to show you that now.
So I put this under the category of if only I had known. So you can upload your image here, the one that you want to be your app's icon. And both places, both Google Play and iOS, require different sizes for their different devices. And it takes a long time to create them by hand. It's resize, resize, resize. So this site lets you upload one image, 1024 by 1024, and you can generate all the images that you need. So it's called appicon.co. You'll thank me later. Next slide.
Yeah, next slide. Okay, now look how easy it is to create these native builds with the Maven command. and the whole setup, right? Gail has shown you the Maven configuration file, so you see how that's set up. And what you do is these Maven commands will specify actions to achieve what's called Maven goals, right? So the build action that you see, the Maven command with the -p iOS option there, is going to run the compilation phase and link all the compiled objects into an iOS executable. The package action that you see underneath the build will create what's called an IPA file that you can submit to test flight for beta testing. And after you connect your iPhone to your Mac with a USB cable, you can perform the run action that you see here. And this command will both install the app created by the build and run the app on your iPhone.
Yeah, and I just wanted to let you know that the to get it on your iPhone, you don't need package. You just use build and run. And package, then you do package after build to create the package that the App Store likes.
Right. All right, let's move to Android now and show you how we set up the Android target. The development environment now for Android is going to be Linux. So if you already have a Linux box, you're good to go. But if you don't, you can do what we did. You can have a virtual Linux OS system running on either Oracle's VirtualBox, which is what we did, or VMware. And for mini-golf, what we did was we installed Ubuntu on our Mac, and we used a VirtualBox for the development. Now, you're also going to need the Android SDK, but fortunately, the Gluon client plugin will automatically download and configure this for you. There's a separate GraalVM Community Edition for Linux that's available on GitHub. And once again, after you download that, you'll have to set those home environment variables that I mentioned. And here, you'll also have to make sure that the required versions for the compiler and the linker, you have those installed as well. And similar to what we talked about a minute ago with iOS targets, the Gluon client plugin will generate default settings and application resources for the Android target. For mini-golf, we used a custom icon set, and we specified once again that the app should run only in portrait mode. And there are also app icon generators out on the web for Android targets if you want to use those.
I just showed you. And I'll think of it. Oh, yeah. What I want to say is that Gluon has really, really good documentation that steps you through both the Android target setup and the one that we just did for the iOS target setup, exactly what you need.
Okay, here are the steps with Maven to actually build the Android native target. The build action that you see here will run the compilation phase and link all the compiled objects into an Android executable. The package action will generate an APK, Android application package, that you can install on any Android device. And finally, the install will load the APK on a connected Android device, and the run action launches the application. Okay, I'm going to turn it back over to Gail, and she's going to tell you about GitHub actions.
Okay, as I discussed before when telling you about Gluon Start, the environment, the ecosystem for JavaFX development is continually improving. And Gluon has decided to leverage GitHub actions to help facilitate some of the building that Paul just described. So except for the slight detail that you still need a Mac to get your provisioning file, but that's a one-time thing, you don't actually need a Mac or a Linux box. You need something, but you don't. If you don't have those, you can use GitHub Actions, and with GitHub Actions, you can use GitHub hosted machines instead of providing your own development environments. And this is really nice for several reasons. One, you always get the most recent, up-to-date machine and development environment, so you don't have to do that. GitHub. It's required that your code is in GitHub, and then it provides runners for all major operating systems. And a runner is simply a GitHub hosted virtual machine that runs your GitHub action workflow. And you define the workflow in a YAML file. And Gluon has created YAML files, and they use actions that both Gluon defined, but also actions specifically defined by Apple and Google that step through the correct process for uploading these your apps to the store. So this diagram here, you see that with Windows, you can use GitHub Actions to build your native executable. Same for Mac OS and Linux. But iOS and Android, not only do you build the native executable, but you can upload them directly to the both App Store and Google Play. So this is really nice, especially after you have your app in production and you're maintaining it. You can, so with this, you can fully automate delivery to Apple App Store and Google Play. And when you make changes, so the changes, the GitHub action gets invoked when you do a push on your repository. And once this is all set up, you can commit and push a change and get an update notification on your phone within minutes that comes from the respective stores. So we haven't actually personally used this because we were through our building before this really got fully developed, but it's something that we plan on getting into and looking into, and we really recommend that you look at it as well.
Great. Okay, yeah, so Gail has just showed you the value of using GitHub Actions for simplifying the deployment of your app to stores. But we thought we'd go ahead and list some of the steps that we did here so you would know what's required to make this happen. And you should know that some of these steps are required and you'll have to do them whether you use GitHub Actions or not. Okay, let's start with the Apple App Store. You'll need a provisioning profile to sign your app. For beta testing, you can run the Maven package action for iOS and submit your IPA file to TestFlight, which we talked about earlier. Then you can upload your app to the App Store Connect using Transporter, which is an app that installs on your Mac. Transporter will verify your application before uploading and make sure that the signing and provisioning is correct. And after you submit your app for review, you'll be notified when it passes. Now let's talk about Google Play. Okay. First, you want to sign up for Google Play Console. I think it's $25 on their website, and then you will get a developer account. And after you create an APK package for your app, you'll then create a key store and sign the certificate, and then upload to the site. And Google Play Console will provide and perform verifications and make sure that the signing is correct when you upload your app to the site.
And they have other, both the stores have other checks. For example, Android looks to make sure you have a minimal Android SDK version that you're supporting. The good news is that Gluon takes care of all that with their Gluon substrate. They orchestrate all that stuff for you.
Mm-hmm. Okay, so here's how you can get the mini golf app. If you're on your iPhone, here's the URL that you can use. It's a tiny URL, but that will take you to the App Store, and you can download the mini golf there on your iPhone. And if you are on an Android device, you can use the second URL there at the bottom to get the app on Google Play. And
or you can also search on either store for mini golf tea time. Tea time is TEE, as in golf.
Right. And yeah, it's really fun. I'm sure you'll do a lot better than I did this morning with it. But at any rate, it is addictive, so I want to warn you. But anyway, have fun with this because we had a lot of fun designing it and implementing it. Okay, let's summarize what we did here in our session. We started off by showing you all the advantages for JavaFX. It's a very powerful UI toolkit for developing mobile applications from one code base. JavaFX brings to the table observable properties, binding mechanisms, listeners, event handlers. It's really fun to write the code, actually. And another thing that you should know is that JavaFX also has background APIs for background tasks that are important because it makes it easy and important to sync your model with your view And so this is another important part of JavaFX that comes along with using the platform to do all this. We also showed you some very useful frameworks, the Gluon framework, and in particular, the Gluon substrate tool that we use to develop the mini golf app. And again, that's based on Open JDK and Open JFX. And then we showed you the GraalVM platform that created iOS and Android native images, once again, with fast startup times and also low memory footprints. And then we also wanted you guys to be aware that GitHub Actions can simplify a lot of the deployment details that you have to go through to get your app configured and up into the stores. Okay. All right, we want to thank everybody for attending our session here. We wish we could be live with you, but that will be happening, we hope, soon. And here's our email addresses and our Twitter handles. We'd like to hear from you. And if you'd like to take a closer look at our code for the mini golf demo that we did today, it's available on GitHub, and here's the URL for that. And we will be posting the slides that we went through just now. They'll be up on our website later in the week. And yeah, I think we're all set.
So if you have any questions in the next 10 minutes,
yeah. So
Kirk will join us.
Will join us now.
Yeah, I'm back.
Thanks, Kirk.
Excellent. Oh gosh. Yeah, so your fan club is out. There's a few questions that came up. Let's see if I can pop them up here. Let's see what we got here. I wrote them down. Is it possible to write an FX application for Apple Watch? Or I guess they're asking what are the limitations?
Yeah, I don't know the answer. I'm thinking, yeah, that's a good question.
That would be cool.
I don't know. I haven't done that. I haven't read any documentation on Gluon about that. So I would think that is probably two dependencies. One is whether the GraalVM will target that as a native build, because that's what's required. And then Gluon does provide a lot of housekeeping and what I guess orchestrating to get all the pieces together.
Yeah, and I would say that, if there's demand for that, if a lot of people want to, start writing some apps with this approach for an Apple Watch, I think that, the ball will start rolling on that, but that would be good.
Okay. That seems good. Let's see what we got here. I was just popping up.
He froze. Hello, Kirk.
How much time does it take to get verified by the Apple Store? I guess this isn't all.
Okay, good question. I think I'm gonna say 1 or 2 days. It was a while ago that I went through that, so I don't remember exactly, but it wasn't a week and it wasn't a day. So I would say 3 or 4 days, 2 or 3 days.
Okay. Right. And another one is, question is, which part of Gluon is freely available? I guess someone is interested in using it for just poking around personal projects, so not a commercial venture. So there was a bit of chatter.
Yeah, I mean, what I showed you, you can go to their site and it says buy, and then they give you. I think if you're a student, I think they're pretty generous about licensing. What I showed you, the Gluon framework with the controls. That's free for anybody, but you have the nag screen. But if you're just trying to figure out what it is, it's not that bad. Of course, if you have your own commercial app, you don't want to have a nag screen. But if it's open, well, I don't know what the rules are, but I know that they do have some leeway for students.
Okay, excellent.
I have to say that we don't work for Gluon.
Yeah, we don't.
And
work for Gluon.
I hope that I haven't said anything in which Gluon's saying, "Oh no, that's not true." But when it gets into things like licensing, I get a little nervous about that. But they have, you know, they are the lead project for JavaFX. They work really tightly with Oracle, and they have, as we showed there, the long-term support for the JavaFX builds. And as you can see, they've already come out with JavaFX 16 early release, and so they're very active in maintaining it and also working closely with Oracle.
Yeah, you would have to say that Gluon has been really responsible for driving FX forward.
Absolutely.
Absolutely. Gluon and the community. So I think I went to a JavaFX conference recently, and the people felt like the biggest problem with JavaFX was more marketing, that people aren't aware of it. And that's because a lot of the high-powered applications that run on the desktop using JavaFX, they tend to be things like banks, the government, you know, NASA, and you don't always get an awareness in the developer community. But people have said one of the main points about JavaFX is that if you're doing a UI code, it's really stable. So if you in terms of if you do a web stack, you have to worry about the libraries getting rewritten every 6 months or 2 years or something. It's just really stable, and it's been around for a while. And with these extra tools, you can see how it can be responsive, and you can even run. There's a company that allows you to run JavaFX stuff in the web as well. And I don't have personal experience with that, but that's also an option.
Now, I have a question for myself. It's like, how do you manage the different aspect ratios for different devices to make sure everything's looking quite...
Well, you can only do so much testing, but for the scaling that we did with mini golf, we just made it as big as it could. And there's for the image view, which is the control that displays images, you could say fit to width and fit to height and keep the aspect ratio constant. So you don't have to worry about weird things with that. In terms of other controls, like you saw the charm list view, that's all handled by Gluon.
Yeah, and they do a really nice job of that, because, you know, that's a big problem with mobile development is having to put in hooks and things for different devices because they display differently or things like that. You know, you don't have to worry about any of that with the Gluon stuff, because you know, you just make the calls to the APIs and you can run, like our mini golf runs on an iPad just as well as it runs on an iPhone and iOS. By the way, it's harder on an iPad because it's bigger, right? So the
answer to that is that not everything is scaled. So the images are scaled and stuff, but anyway, that really that's not really Gluon. The Gluon mobile stuff we don't use for mini golf. So we used it for what you saw, the blood pressure monitor, and how the list view component with the headers and things like that. That they spent a lot of time making these components scale well within the mobile environment. So I'm sure there's a lot of heuristics they go through with skinning them correctly. That's beyond my knowledge set.
Excellent. Well, we're just about at the top of the hour. So thank you, Paul, and thank you, Gail, for
thank you for having us.
Thanks for moderating us.
Yeah.
There's lots of nice comments here saying, I enjoyed the session. I didn't know anything about the topic, but you were very clear. Thank you. And I would have to agree.
Great.
Because, yeah, thumbs up. So, right. I will end the broadcast and let everyone go for the day. And there will be more sessions tomorrow. And do enjoy.
Okay.
Thank you.
Okay. See you.